I don't think there's anything in math that has been more appropriately named than complex fractions. Hey, I'm Tammy, and I do math for coffee. Thank you for being here. Let's jump into it right now. A complex fraction is something like this, where you have 2 divided by x, and all of that is being divided by 3 over y. So they write it like this sandwich of fractions. That middle fraction bar is the division operator. The way you handle these is you rewrite them using fraction operations for division, which is that skip, flip, multiply thing. If you don't know what I'm talking about, I'll put a link in the corner for the fraction review I made for people who are in upper level math courses. But you might get it just from watching me do this problem. We rewrite the numerator as 2 over x, don't change anything, being divided by 3 over y. Now in the next line, we change them to multiplication by flipping the second fraction over. This is going to become 2 over x multiplied by y over 3. Multiply straight across, we get 2y over 3x. In the world of complex fractions, this is actually a pretty easy one. So let's try to up the difficulty here. All right, here you go. 1 plus 2 over x, all being divided by 4 minus 6 over x. We need to deal with the numerator and the denominator on their own before we try to put this all together. The 1 in the numerator has to have a common denominator with the second fraction so that you can add them together. Well, to make that, you just rewrite 1 as x over x plus 2 over x. When you add those, you get x plus 2 over x. Let's look at the denominator. To get a 4 to be a fraction that has a denominator of x, we're going to put 4x over x minus 6 over x. Combine those, we get 4x minus 6 over x. We have a fraction on the top and a fraction on the bottom. Recopying the numerator x plus 2 over x, we're going to multiply that times the denominator flipped over, which then becomes x over 4x minus 6. The x's are going to cancel each other out. So we end up with x plus 2 over 4x minus 6. And you can factor out a 2 on the denominator, but it's not going to cancel with anything in the numerator, so I'm just going to leave it the way it is. For this one, we actually do have a fraction over a fraction. Copying the numerator, we get 3 over x plus 1. We're going to multiply that times the denominator flipped over, x minus 1 over 5. Multiply straight across, we get 3 times the quantity x minus 1 over 5 times the quantity x plus 1, distributive property, 3x minus 3 over 5x plus 5. That one is actually pretty simple. Starts out looking pretty bad, but it works out nicely for a complex fraction. We do have a fraction over a fraction with this one as well, but there's going to be more to it once we get into it. Let's start by rewriting it as a multiplication problem with the denominator flipped over. X plus 3 over x minus 3 times 3x minus 9 over x squared minus 9. There's some factoring that needs to be done here, so I'm just going to go ahead and do that right now rather than trying to multiply everything out. Multiplying these things would make this problem a lot messier. It's better to factor and do some canceling first. So x plus 3 over x minus 3 stays the same, but I can pull a 3 out of the numerator of the second one, and that becomes 3 times x minus 3. And x squared minus 9 can be factored into x plus 3 times x minus 3. We have some stuff all over the place that can be canceled. Now remember, you can only cancel factors. You cannot cancel numbers that are being added and subtracted. Everything that's left over is the answer. In the numerator, the only thing that's left is a 3. And in the denominator, the only thing that's left is an x minus 3. If your class is working on rational expressions, click into this video right now. Check out this playlist as well. Thank you for being here, and I will see you next time.